Hello friends, today I'll discuss about minors and cofactors. Also we are having the topic of adjoint of a matrix, how to find the adjoint and few examples. So let's start with the first examples. Let's find the minors of a given determinant this. So let's calculate the minor of the first element A11. So what's the procedure? We have to remove the row and the column corresponding to this element, and the determinant formed by the remaining elements will give the minor of the element A11. So we are having the minors with these elements. Similarly, if we want to find the minors of the element A12, we have to ignore the row and the columns containing that particular element, and the determinant formed by the remaining elements, this, and this. So these four elements will give the minor of A12. Similarly, the minor of element 1A13 can be calculated like this. We will remove these two, this row and this column, and the determinant formed by these remaining elements will give the minor of element A13. So similarly, if we want to find the minor of this element A31 or A32 or A22, we apply the same technique. We just remove the row and the column containing that particular element, and we can easily find the minor of that particular element. Okay, so now let's find the cofactors of a determinant. So what is the cofactor? If the minors mij is multiplied by a quantity minus 1 to the power I plus j is called the cofactor of that element aij, where I and j are the row and column numbers. Therefore, the cofactors of the first element, if we want to find the cofactors of the element A11, we have to first find the minor that I have discussed previous slide. Yeah, we have to remove these row and columns, and the remaining elements will give me the minor like this, and this minor is then multiplied with a number with a quantity like minus 1 to the power I plus j. So for the first element, the value of I is equal to 1 means the first row, and the value of j is equal to 1 means the first column. Okay, so this will give me the positive value, and the value of this determinant can be calculated like this. We'll just multiply diagonally, and then we just remove it by multiplying these two elements. Okay, this minus this. So this is the cofactor of the first element A11. Similarly, if we want to find the cofactor of A12, the second element, so similarly we will first find the minor by just removing the row and the column numbers containing the element A12. So then we'll form the minor with the remaining elements like this. Okay, this, which will be multiplied by minus 1 to the power I plus j. So this is the first row and second column, so it is 1 plus 2. So this will give me the negative value, and the determinant of this minor is like this. So similarly, if we want to find the cofactors of the other elements, these, we will apply the similar technique, and we can easily find the cofactors of the remaining elements of the determinant or of a matrix. Okay, now let's discuss about the adjoint of a matrix. Okay, the adjoint of a matrix is defined as the transpose of cofactor matrix. So what we have to do, we at first have to calculate the cofactor of the matrix. For example, if we are having the matrix A, which is a 3 cross 3 matrix, so initially we have to find the cofactors of each of the elements. For example, the cofactor of element A11 is capital A11. So we'll first find all the cofactors like this. The cofactors of A12 is equal to capital A12 like this. We'll find all the cofactors corresponding to all the elements, okay, and we will place like this. So after forming this matrix, we'll take the transpose of this new matrix, okay, and the transpose of the new matrix is called the adjoint of the matrix A. So what is the transpose of the matrix? We'll just interchange the column or interchange the row into a column like this. The second row will come like this, and the third row will come like this. So the final adjoint of the matrix A is given by this matrix. So there are some properties of the adjoint of a matrix. The first property is that if we multiply the adjoint A with the matrix A itself, or otherwise if we multiply the matrix A with the adjoint of matrix A, this will give the determinant of the matrix A multiplied by the identity matrix of the same order. Okay. The second property is that if A is a square matrix of order n cross n and the determinant of the matrix A is given by m, then the determinant of the joint of matrix A is given by m raised to the power n minus 1.